Student. So we start sharing screen. So this video is continuation to the last video where we have started the solution of non-homogeneous linear differential equation. In that particular video, we have discussed the solution of non-linear differential equation using the method of variation of parameter and method of undetermined coefficient. So in this particular video, we'll discuss that how can we find out the solution of non-homogeneous linear differential equation using operator method, and also we'll discuss the special form of linear differential equation with variable coefficient, which is said to be Euler-Cauchy equation. So firstly, I'll just recapitulate what do we have, what kind of non-homogeneous differential equation we have. The general non-homogeneous differential equation, it can be written in the way f of t of y equal to rx. Basically, f of t here is nothing but a polynomial in D, because in general we are assuming the nth order differential equation as a not nth order derivative y with respect to x plus a1 and minus 1th order derivative y plus so on a and y equal to rx. Here rx is the non-homogeneous part of a differential equation. So when we express this equation in the operator form, we replace nth order derivative with d power n minus 1th order derivative d power n minus 1 and so on, where d represents the differential operator dy dx. So in that case, the solution of this non-homogeneous differential equation is the sum of complementary function and particular integral, where the complementary function we denote it with yc and particular integral we denote it with yp. So for the complementary function, we are assuming the homogeneous differential equation. That means we are assuming Rx equal to 0. So because it is a nth order differential equation, so when we write its complementary solution, it has n linearly independent solution, and the general solution is the linear combination of these n solution c1y1 plus c2y2 plus on cn yn, where because the order of the differential equation is n, so it has n arbitrary constant in the general solution. For particular integral, we are assuming let y be a particular integral, then the particular integral is basically the solution of non-homogeneous part. That means if I substitute y equal to yp in this equation, then after solving the left hand side, you will get the right hand side. So this is the particular integral. But in this case, we are going to use the operator method. So operator method means that we are using here the operator. So the first thing is we need to know that f of t and 1 upon f of t, they are inverse operator like d and 1 upon d. What is d? D is the differential operator d by dx. So 1 upon d, it is assumed as an integral operator. They are inverse operator. So in general, f of t and 1 upon f of d, they are inverse operator. So that means when we take the product of these two, it is 1. So to calculate the particular integral, the first step is we are going to apply 1 upon fd. That is, we apply the inverse operator. So our purpose is to calculate 1 upon f of t rx. Now we are going to discuss what are the different properties which we are going to use here while calculating the particular integral. So there are about 7 properties. So the first one is the special case if we are assuming f of d is equal to d. Although we are solving a linear differential equation of higher order, but these are just the special cases that if we assume f of t as d, then what is your particular integral? 1 upon f of d rx. So f of d become d, so 1 upon d rx. And because if d is the differential operator, then 1 upon d is the integral operator. So 1 upon d rx we can calculate by integrating rx. The second property is special cases if f of d is d minus a, that is if it is a linear factor. Then to calculate the particular integral, what is the property we have? then 1 upon d minus a rx can be calculated as e power ax into integration of e power minus ax time rx dx. That means if we have here a negative sign, then outside the integral we have a positive sign, and inside the integral we have a negative sign. Multiplied with rx, solve this integral, and then multiplied with e power ax. Case number 3 is about the non-homogeneous function. So if Rx is e power Ax, then how do we calculate the particular integral in that case? Simply replace d with a, but condition is f of a should not be equal to 0. And if f of a is 0, then we multiply x in the numerator, we differentiate this operator function with respect to d, and then apply this operator on e power ax again. Like again, we can use the same property if after calculating its derivative, again we replace d equal to a. If it is non-zero, then we can get the solution. If it is again 0, then again we multiply it with x and we continuation this process. Next case is if your non-homogeneous function is sine or cosine function. If it is sine or cosine function, then to calculate the particular integral, we simply replace d square with minus of a square. So either we have a sine ax function or we have a cosine ax function. But again, the condition is your denominator should not be equal to 0. And if your denominator is 0, like the exponential function, we have the same property, multiply by x, and again differentiate your denominator function with respect to d, and again apply this operator on rx. Next property is if your function is algebraic function like x power m, then what can we do? We simply take the constant term outside from this polynomial function so that we can express our function as 1 plus phi of t. Like, suppose that our function is d square plus 5d plus 7. So if I take this constant term 7 outside, so we left with 1 plus d square plus 5d by 7, and we name this as phi d. Okay. So sometime it may be possible that constant term is not there. Your f of t may be d square plus 5d only. If constant term is not there, we can simply take the smallest power term outside, complete term outside, so that it is d upon 5. So we are expecting d in the numerator only, because after taking it into numerator, we apply the binomial expansion of negative index. Okay, so we can use the identity 1 plus a d power minus 1 as 1 minus d plus a d square minus d cube, and so on. And because this side we have x power m, so what is d? D means derivative of this function. Derivative of x power m is m times x power m minus 1. And here we are assuming m belongs to positive integer, or you can assume natural number only. So after finite number of term, its derivative will be 0. Next property is if we have Rx as product of two function, one is algebraic exponential and other is any other function, then we can take the exponential function outside and we replace here d with a d plus a. In case of product of two function, just keep this exponential function outside and replace d with a d plus a, and then apply this operator on the other function vx. It will give us the, or like it depend upon that what kind of function we have, we can apply the property. If it is sine or cosine, we can use this property. If it is algebraic function, then we can use this property, and so on. Apart from this, we have one more property. If we have a product of two function where one is x, other is any other function of x. Okay. So again, this property is different from the exponential one. If we have a e power x with any other function, then we always use this property. Okay, so here Vx may be x, but here Vx should be other than the exponential function. Only then we can use this property, because it is not the easy property like the exponential one, right? In this case, the property is x taken outside, apply this operator on V, and then the derivative of this is f dash d upon f of t square apply on V. Okay, now let us start with the problem where we are going to use this property here. So the question is we need to find out the solution of this problem. Solution means the complementary function and particular integral both. But in this case, if you can see here, all the four options having the same complementary function. So it means that our main interest is to find out the particular integral, right? So what is the particular integral? So for particular integral, firstly we apply the inverse operator. 1 upon d square minus 5d plus 6, and our function is e power x into cos 2x. So it is the product of the two functions. So here we can use the property 1 upon f of d e power ax into v. In that case, what is the property? E power ax taken outside, replace the d with a d plus a, and apply this operator on vx. So, so here e power x taken outside, what is a? A is the coefficient of x, which is 1. So we are going to replace d with a d plus 1, and apply this operator on cos 2x. So this is e power x. Here we have d square plus 2d plus 1 minus 5d minus 5 plus 6 cos of 2x. Now you can see here d square is there. This is 2d minus 5d. So we have e power x 1 upon d square minus 3d, plus 2d minus 5d is minus 3d, and the constant term is 1 plus 6 is 7, 7 minus 5 is plus 2 time cos 2x. Now it is of the form 1 upon f of d into cos ax. So what about in case of cosine function? In case of sine or cosine function, we are going to replace a d square with a minus of a square. This is the property we have. We have a sine or cosine function. We are replacing d square with minus of a square, provided it is not equal to 0. So what is a here? A is 2. So we are going to replace d square with minus of 2 square, that is minus 4. So if we replace it here, then we can get e power x 1 upon minus 4 minus 3d plus 2 times cos 2x. So basically it is e power x 1 upon minus 2 minus 3d times cos 2x. So now there are two ways to solve this one, because it is like a linear factor. Okay, because if I take minus 2 common, then it is of minus 3 common, then it is of the form d minus a or d plus a. So we have a property that 1 upon d minus a rx, this is equal to e power ax integral e power minus ax times rx dx. This is one of the way, but it is bit lengthy. Otherwise, what can we do? So I'll try to convert it into the quadratic one. If I take the negative sign common, this is 2 plus 3d. To make it quadratic, I'll just consider it as a plus b, and if we operate it with a minus b in the numerator and denominator, then this is of the form a plus b, a minus b is a square minus b square. Let's continue this side. So we can get here, this is minus e power x, and here we have 2 minus 3d in the numerator, and in the denominator this is 4 minus 9d square time cos 2x. So again, in case of sine cosine function, we are going to replace d square with minus of a square. Minus of a square is minus 4. So this is minus e power x 2 minus 3d times cos 2x, and here this is 4 minus 9 times minus 4. And what is d here? Here d stand for d by dx, the differential operator. So if we differentiate our function, then this will gives us minus e power x. This is 9 into 4, 36. 36 plus 4 is 40. And this is 2 times cos 2x. And derivative of cos is minus 2 sine 2x. Minus 2 times sine 2x. Right? And I can take minus 2 common. So minus and minus become positive. So it is e power x 2 common. It is 2 times e power x upon 40. And here we have cos 2x plus 3 sin 2x. It is 2, 1 ka 2, 20. So answer is e power x upon 20. Negative sign retained here because this negative and negative become positive. So e power x upon 20 cos 2x plus 3 sin 2x. Cos 2x plus 3 sin 2x e power x upon 20 will negative sign. So this is the particular integral. It means that this is the correct answer. Okay. So here we have used two property. One is if we have an exponential with any other function of x, we can take exponential function outside, replace d with the t plus a. After that, depend upon the kind of function present here, we are going to apply the property. Like here we have a trigonometric function, replace d square with minus of a square. Now we left with the linear factor, again convert it into quadratic by operating a minus b. If a plus b is there, then again replace d square with minus of a square. Your denominator is constant, but in the numerator, you can operate like 2 minus 3d means 2 times cos 2x minus 3 times derivative because d is a differential operator. Derivative of cos 2x is minus 2 sin 2x. d of cos 2x means minus of 2 sin 2x, which we have used here, right? So you can get the particular integral. Okay, now let us consider the next problem. In this case, again, the question is we need to find out the particular integral. So for particular integral, firstly we need to write the operator form. Second order derivative, this is the t square 4d plus 3 times y equal to 3 times e power 2x. So for particular integral, we are applying the inverse operator, that is 1 upon d square plus 4d plus 3 times 3 e power 2x. Use the linearity property like the other operator. This operator also holds the linearity property. So 3 taken outside. So now we left with the exponential function. Now it is of the form 1 upon f of d e power ax. This is 1 upon f of a e power ax, provided f of a is not equal to 0. So use this property here. What is a is 2. This is 2 square 4 into 2 plus 3 e power 2x. This is 3 times 1 upon 2 square is 4. 4 into 2 8 plus 3 e power 2x. So 12 plus 3 is 15. And here we can cancel out 3 1 ka 3 5 ka. So answer is 1 by 5 e power 2x. This is the correct answer. Right? So in this case, we simply use the property 1 upon f of t e power ax as 1 upon f of a e power ax because f of a is not equal to 0. Now let us consider the next problem. Okay, in this case, we need to find out the complementary function as well as particular integral. Okay, so for the complementary function, so firstly we consider the homogeneous differential equation. For the complementary function, we consider homogeneous, but in the operator form, it is fourth order derivative plus second order derivative yc equal to 0 because there is no constant term here. So we are assuming let yc equal to e raised to power mx be its solution. So what is its auxiliary equation? Replace d with m and drop the dependent variable. M power 4, 3m square is 0, m square is common, m square plus 3 is 0. So it means m square is 0 and m square plus 3 is 0. So m square is 0 means m equal to 0 and 0, and m square plus 3 means m equal to plus minus square root of 3 iota. Roots are complex because if the square of a number is negative, it means the root must be complex. So the solution is root is repeated c1 plus c2x, and here real part is 0. It is e power 0x c3 cos root 3x plus c4 sine root 3x. Okay, because e power 0x is 1. Because root are repeated, so the solution is c1 plus c2x. If it is repeated 3 times, c1 plus c2x plus c3x square, because the number of arbitrary constant equal to the number of root of the auxiliary equation or the order of the differential equation, right? So two roots are 0 0, so it is c1 plus c2x e power 0x. If one solution is e power mx, the another linear independent solution is x times e power mx. Okay. Now this is one of the solution. Now if we just look at the option, so A and D containing C1 plus C2x, the sine and cosine function. So here C1 is missing, here, here X's term is missing, so it is not the order. Although here we have an arbitrary constant C also, which is not the correct. Because in particular integral, your particular integral is always free from arbitrary constant. Because the number of arbitrary constant present in a differential equation, it should be equal to the order of the differential equation. Because the order is 4, so it must contain exactly 4 arbitrary constant. Okay, so it means that this constant should not be there, but anyhow we'll try to find out the particular integral. So in this case we have yp, we apply the inverse operator 1 upon d power 4 plus 3d square 108 times x square. So again use the linearity property, and here we have the algebraic function, so I can take 3d square common. We have 1 plus a d square upon 3 and x square. So here we have 336. So this is 36 upon d square, and we take this factor in the numerator and apply binomial expansion. Now here we already have a d square. D square means second order derivative, and second order derivative of x square is x square is 2, and if we take higher power means fourth order derivative is 0, so it means that we need to expand up to one term only. Okay, so this is 36 upon d square 1 minus d square upon 3 plus d power 4 upon 9 and so on times x square. So this is 36 upon d square x square, second order derivative is 2, all higher order derivatives are 0. Now we left with 1 upon d square in the denominator. One more important thing, although we have a 2 operator term, but we are not firstly applying d square because 1 upon d of rx is integral of rx. So if we firstly integrate the function, in that case we'll get higher power of x. Accordingly, we need to open more number of terms here. Okay, so it will be better that firstly apply this operator on this algebraic function and then you can integrate your function, right? So now we have a d square means we need to apply 2 times 1 upon d. So 1 time d means integral. So 1 integral gives us 36 by d. Integral of x square is x cubed by 3. minus 2 by 3x. Again use the property, so it is again integral of x cubed by 3 minus 2 by 3x dx. So integral of x cube is x power 4 by 12, and this is 3 into 2. Going to get cancel out. So if you multiply 36, so it is 3x power 4 minus 3 1 12 times x square. So this is your particular integral, 3x power 4 minus 12x square. Right, 3x power 4 minus 12x square. So this is the correct option. Although this is also here, but here C2x x term is missing here, so that's why this option is not the correct one. So this is the correct answer here. Suitable one, because although here we have arbitrary constant, our arbitrary constant should not be there. Okay, so this is the correct answer. Okay, now move to the next problem. Again, we are having the algebraic function, and we are interested to find out particular integral. Let us quickly do this. So the operator form is d square plus d. Now for particular integral, we apply the inverse operator. And again, because there is no constant term, so we are taking smallest power term, that is d. So we have 1 plus a d power minus 1 x square plus 2x plus 4. But now it is a quadratic polynomial. So in this case, second order derivative of quadratic is constant, because what is d of x square plus 2x plus 4? D stand for derivative. It is 2x plus 2. What is the d square of x square plus 2x plus 4? It is 2 time differentiate. Derivative of 2x plus 2 is 2. And d cube of x square plus 2x plus 4 means derivative of 2. It is 0. So here we have x square plus 2x plus 4. Now we are going to apply this. When we open this bracket, we get x square plus 2x plus 4. This is the first term. Minus, its derivative is 2x plus 2, plus second order derivative is 2, and all our higher term are 0. So here this plus 2 and minus 2 get cancel out. This minus 2x and plus 2x get cancel out. So we're left with 1 upon d times x square plus 4. And what is 1 upon d of Rx? This is integral of Rx. Integral of x square plus 4, that is x cubed by 3 plus 4x. So x cubed by 3 plus 4x. It means that this is the correct answer. Okay. Now let us move to the next question. Now again, this problem is based on the particular integral of this differential equation. So firstly, we write the operator form d square plus 4y equal to sine 2x. So for particular integral, we can consider yp as 1 upon d square plus 4 sine 2x. Now in case of sine and cosine, the property is 1 upon f of d of sine ax is equal to 1 upon f of d, replacing d square equal to minus a square times sine x. But condition is that f of t on replacing d square equal to minus a square, it should not be equal to 0. So what is a here? Here is 2. So what is d square? It is minus 2 square, that is minus 4. It means that d square plus 4 is 0. So in case of failure, what we need to do? We multiply x, differentiate denominator function with respect to d, and then apply this operator on sine. So we are going to multiply x, differentiate d square plus 4 with respect to d, and then we need to apply this operator on sine 2x. What is its derivative? It is 1 by 2d. Again, we have a linear d only. What is d? 1 upon drx is 1 upon drx. Is again integral of rx dx. So x by 2 is already there. Integral of sine 2x, and integral of sine is minus of cos 2x upon 2. So answer is minus x by 4 cos 2x. Right? Okay, now let us move to the next problem. Now this time we are given, we need to calculate the particular integral, and inverse operator is already given. It is already given in the form of 1 upon f of t. But here we have a cos 2x. In case of cosine function, we need to replace d square with minus of a square. But here we have a linear factor. What can we do? If a minus b is there, a plus b. So it is equal to d plus 1. And here it is d square minus 1 cos 2x. So what is a? A is 2. So we are going to replace minus 2 square minus 1 d plus 1 cos 2x. So this is minus 1 by 5. Derivative of cos 2x is minus 2 sine 2x plus cos 2x. Or otherwise we can also use the other property. We have one more property, that 1 upon d minus a rx as e power ax e power minus ax into rx dx. We can use this property also. So if we use this property, 1 upon d minus 1 cos 2x, then this is e power x e power minus x into cos 2x dx. And here we can use the property of integration, that e power ax into cos bx. This is e power ax upon a square plus b square, a cos bx plus b times sin bx. So we use this property here. We have, what is a? A is minus 1. What is b? B is 2. A cos bx plus b sin bx. So this e power x and e power minus x, they will get cancelled out. So we have 1 upon 4 plus 1 is 5. 2 sin 2x minus cos 2x. So you can see, if I take this negative sign inside, then this is negative, this is positive. Right? So again, you will get the same answer. So it depends upon you, that whatever the property you are convenient with, you can use that property. Okay, let us move to the next problem. Now again, the question is, we need to find out the particular integral 1 upon d square minus 9 e power 3x. So we have a property 1 upon f of t e power ax as 1 upon f of a e power ax, but the condition is f of a should not be equal to 0. And if I replace here 3, so what is 3 square minus 9? This is 9 minus 9 is 0. So in case of failure, we have multiply x, differentiate denominator function with respect to d, and then use the property if f of a is 0. So we multiply x, differentiate denominator function with respect to d, and then again apply the property. So this is 1 upon 2d e power 3x. So again we have a two-way. One is 1 upon d rx means integral of rx dx, or you can use again this property by replacing d equal to a. If we replace d equal to a, this is 1 upon 3 power 3x, that is x by 6 e power 3x, or you can consider x by 2 integral e power 3x. Its integration is also e power 3x upon 3, x upon 6 e power 3x. So you will get the same answer. Either you can use this property or you can use this property. So your answer is x by 6 e power 3x. Okay, so these are some problems based on the operator method. Now we are going to discuss the Euler-Cauchy equation. Okay, so basically Euler-Cauchy equation is a special type of linear differential equation with variable coefficient. It is of the form a naught and a third x power n and a third derivative y, a1 n minus 1 power of x and minus 1 a third derivative y plus so on a n y equal to rx. So basically it is a differential equation with variable coefficient, but the special thing is here the power of x and the order of derivative, it is same in each term. So if we convert this differential equation into a differential equation with constant coefficient, then we can find out the solution easily by using operator method. Okay, so in this case we need to do only one additional step to convert this equation into a differential equation with constant coefficient. Now how do we convert this? Just imagine the simple one is x divided by dx. The power of x is 1, the order of derivative is 1. So I want to remove this x from here. So what can we do? I can write it as 1 upon x dx. And 1 upon x dx can be written as derivative of log x. So if I assume log x as some variable, say log x equal to z, then this is nothing but dy by dz. Now you can see here this variable is now not available. So what we need to do to reduce this equation into a differential equation with constant coefficient, we transform the variable log of x equal to z, or x equal to e raised to power z. So if we use this transformation, then x dy upon dx, it will be replaced with a dy by dz. Okay, that means x dy. This is theta y. What is theta? Dy dz. And what about second order derivative? X squared d square y. This will be theta into theta minus 1 into y. And third order derivative, x cubed d cubed y. It becomes theta, theta minus 1, theta minus 2 into y, and so on. One derivative, theta, two derivative, two consecutive term, three derivative, third order derivative, three consecutive term, fourth order derivative, four consecutive term, and so on. So if we just replace in this way, so you can find out here that there is no variable here, only operator term is there. So automatically your differential equation converted into a differential equation with constant coefficient, and you can find out the result or solution of the problem easily. Let us apply this concept to find out the solution of some problems. So firstly, we are given a homogeneous differential equation. So we need to see that what is the general solution in this case. Okay. So to convert this equation into constant coefficient, we use the transformation, we use the transformation log of x, let it be equal to z, or x equal to e power z, and we replace xy dash with theta y, x square y double dash with theta into theta minus 1 into y. How do you know that we need to use this transformation? Because the power of x and the order of derivative, they are same in all the term. And although it is already written, but if it is not written there, how can you identify? You simply need to check that the order of derivative and the power of x is same, and where we have only y, there is no power of x. Okay. Now if we use this transformation, then x square y double dash become theta into theta minus 1. X into y is theta y plus y equal to 0. So this is theta square minus theta plus 1 into y equal to 0. But what is theta? Theta is d by dz. This is the important thing. This is theta square minus 2 theta plus 1 into y equal to 0. That is a homogeneous equation. For the homogeneous equation, we are assuming let y equal to e raised to the power mz. This is the important part. So now your independent variable is z. So in this case, our assumption is let e power mz be its solution. So we write its auxiliary equation by replacing theta equal to m square minus 2m plus 1 equal to 0. 1 square is 1. So basically it is m minus 1 whole square. So it has a 2 root, 1 and 1. Roots are real but equal. So the solution is, how many times root repeated? 2 times. So we have a linear c1 plus c2. Again here z, because your independent variable is z. c1 plus c2z e raised to the power z. But we are given equation in x and y only, so we need to write answer in y and x. So what is z? Z is log x. And what is e power z? It is x. So answer is c1 plus c2 log x into x. Now let us see which of the option is correct. c1 plus c2 log x into x. This is right. c2 plus c1 log x, because c1 and c2 they are constant. I can write in any order. c1 minus c2, if c1 is constant, then minus c1 is also constant. So this is also the correct option, and this is also the correct option. So in this case, all the four options are correct. Okay. So sometime the constant is given as minus c2. Minus c2 means it is again plus c2 only, because c2 is arbitrary constant. It may be positive, it may be negative. It doesn't matter. Okay. So in general, we used to write in a positive form, but when we are given the options, so it in this case you need to cross check that either it is given positive sign or negative sign. Both the ways, the answer can be written. Okay, let us consider the next problem. So we need to find out the particular integral here. 1 upon x square d square plus 2 16x square, and here d stand for d by dx. So now what do you find out here? Here we have a d is a differential operator, but beside this, the order of derivative and power of x is same. So it shows that it is a Euler-Cauchy equation. It is a Euler-Cauchy equation. It is a Euler-Cauchy problem. So what we need to do? We need to firstly transform it into a differential equation with constant coefficient. So you need to use the transformation. Use transformation. For transformation you can use log of x, let it be equal to z, means x equal to e power z. And what is xd? This is theta y, and x square d square y, this is theta into theta minus 1 into y. So what we are going to do, we are going to replace x square d square with theta into theta minus 1. We are not writing y because y is already in the left hand side. We are simply considering the function of t. Okay. If you have any confusion, you can take this factor in the left hand side first. X square d square plus 2y. This is equal to 16x square. Okay. Now you can convert it into theta form and then take it in the right hand side. But it is obvious that first order derivative replaced with theta, second order theta into theta minus 1. Okay. And this 16 is taken outside. What is x? X is e power z. So x square means e power 2z. So it is theta square minus theta plus 2 e power 2z. Now it is an exponential function. So here we can use the property 1 upon f of the e power ax. It is 1 upon f of a e power ax, provided f of a is not equal to 0. So because it is in the exponential form, so we can use this property. It is 16 times 1 upon 2 square minus 2 plus 2 e power 2z. This 2 and 2 get cancelled out. This is 16 upon 4 e power 2z, 4 times e power 2z. Now we need to write answer again in the form of x, that is 4. What is e power z? Is x. X is square. 4x square. Okay, so basically it is x cubed. X cubed means it is e power 3z. 3z means 3 square plus 3 plus 2. So 9 plus 2, 11 minus 3 is 8. So 8 1 the 8 2 bar. So it is 2 times x cube. Okay, basically it is x cube. Let me increase the font size. So it is x cube, right? So x cube means here it is e power 3z. Okay, so basic the important point is when we have x squared d squared, the power of x and the operator power is same. It means that it is a Euler Cauchy problem. We need to transform it into the with constant coefficient by using this transformation, and then whatever the kind of function is there, we can use the property here, and then you can get the answer easy. Okay, now let us try the another one. Now again, it is the problem of the constant coefficient. Let us see here. Here again the power of x and the order of derivative is same, so we are using the transformation. Using transformation, log of x equal to z or x equal to e power z. So x y dash is theta y, x square y double dash is equal to theta into theta minus 1y, where theta stands for d by dz. So your equation now reduces to theta into theta minus 1 minus 5 theta plus 9 times y equal to 0. It is theta square minus 6 theta plus 9 into y equal to 0. Now let y equal to e raised to the power mz, because theta is d by dz. Again, I am repeating, this is an independent variable. We are assuming e power mz be its solution. So its auxiliary equation is m square minus 6m plus 9 equal to 0. Again, it is a perfect square. So the value of m is 3 and 3. Root are repeated. So the solution is c1 plus c2z e power 3z. So c1 plus c2 log x times x cube. Again, this one, this one, this one, this one, all the four options are correct because I can interchange these two constant and I can take plus or minus constant. It will not make any effect because C1 and C2 they are arbitrary constant. Okay, so all the four options are correct. Now let us try the another one. Okay, again we need to find out the particular integral here. So for the particular integral, again transform equation using log of x equal to z, x equal to e power z, x y dash equal to theta y, x square y double dash equal to theta into theta minus 1 into y. What is theta? d by dz. How do we know that? Because here the power of x and the order of derivative they are same. This is second order derivative, right? So your equation becomes theta into theta minus 1 minus 2y equal to 2x plus 6. So we are interested to find out the particular integral only. So for particular integral, we apply the inverse operator. 1 upon theta square minus theta minus 2. Sorry, we need to replace x with, what is x? X is now e power z. This is e power z. 2 times e power z plus 6. So this is 2 times theta square minus theta minus 2 e power z plus 6 times theta square minus theta minus 2. Now there is no function here, no function is, I assume e power 0 z. Again use the property 1 upon f of d e power ax as 1 upon f of a e power ax. If we use this property, it is 2 times 1 upon 1 minus 1 minus 2 e power z, 1 upon 0 minus 0 minus 2 e power 0 z. This is 2 times minus 2 e power z. This is 6 upon minus 2. This is minus, this is equal to minus e power z minus 3. And what is e power z? This is x. So answer is minus x minus 3. This is the correct. Okay, now one more problem here. The question is we need to find out the particular integral. Okay, so the question may be given in this way, like sine of log of x square. Log of x square can be written as 2 times log x using the property of logarithmic function. Log of a raised to power b is b times log. Okay, so again you can see here the power of x and the order of derivative is same. So we use the transformation using log of x equal to z or x equal to e power z, x dy equal to theta y, x square d square y is equal to theta into theta minus 1 into y. What is theta? D by dz. So you can get here as 1 upon theta into theta minus 1 plus theta times sine of 2. What is log x? It is z. So it is 1 upon theta square minus theta plus theta sine 2z. So this theta square and theta get cancelled out. 1 upon theta square. And we have a property. What we are going to do in case of sine or cosine function? Replace d square with minus of a square, provided your denominator is not equal to 0. Okay, so suppose that here we have a plus 4. If we are considering here plus 4, then what if we replace theta square with minus 2 square? It is minus 4. And theta square plus 4 is 0. So what we need to do? We need to multiply independent variable. So which variable we need to multiply? Now our independent variable is z. So we need to multiply it with z, and you need to differentiate denominator function with respect to theta, right? And then applied it on sine to z, because here we are saying that in case of Euler, we need to multiply x, differentiate denominator function with respect to d, and apply this property, because here our independent variable is x, so we multiply it with x. So here our independent variable is z, so we need to multiply it with z. So what do we get here? It is z times 1 upon 2 theta sine to z. And what is the meaning of 1 by theta? 1 by theta means integral, because 1 upon drx is integral of rx dx. So 1 upon theta, some function of z, it means integral of this function. It is integral of sine 2z dz. So its integral is minus cos 2z upon 2. So answer is minus 1 by 4 z cos 2z. Now what is z? Log x. So what is the value of this part? It is minus 1 by 4 log of x into cos of 2 times log of x. This is the particular integral of this problem. Okay. So the important thing is, when we have a variable coefficient, so you need to identify that either it is a Euler-Cauchy equation. How can you identify? Just check that the power of x and the order of derivative is same. If it is so, firstly transform your equation into a differential equation with constant coefficient using this transformation. Sorry. Log x equal to z is the transformation, and x equal to e power z. So when we use this transformation, your differential equation converted into a differential equation with constant coefficient, and the rest of the cases simply use the operator method. One more important point I just recall. Yeah, like when we are calculating the auxiliary equation, okay, the solution of the homogeneous differential equation, we are assuming e raised to power mz be the solution. What is e power z? It is x. So basically, we are assuming y equal to x raised to power m be its solution, right? So for example, if we substitute here x square y double dash minus 5x y dash plus 9y. So what is the second order derivative of x power n? It is m into m minus 1 times x power m minus 2. This is m into x power m minus 1 plus 9 times x power m equal to 0. If we take x power m common, so what do we have here? M into m minus 1 minus 5 times m plus 9 equal to 0. Obviously, x should not be equal to 0, because the condition that the differential equation is normal is the leading coefficient should not be equal to 0. So x is not equal to 0. So what we have here, m square minus 6m plus 9 equal to 0. So this is the auxiliary equation. Okay, so sometimes the question is asked that what is the trial solution for the homogeneous differential equation in case of Euler-Cauchy equation? So the trial solution is x power m. Like in case of constant coefficient, we are assuming e power mx be the solution. Okay, but in case of Euler-Cauchy equation, x power m be the solution. Okay. Okay, so this is all about your this topic. I hope you will get an idea that how can we solve the problem based on the linear differential equation part. If you still find out any doubt or inquiry, you can post your query in the comment box. I'll try to provide you the solution of the same. Thank you and have a nice day.